8.9, solving a system of equations with the addition method. This is also known as elimination. So first, we want to ask, what is a system of equations? A system of equations is a set of two equations that share a common point, and this point is the solution to the system. They can be used to solve for real-world situations, break-even point for business production, the number of items that need to be bought or sold, and other applications. And the solution to the system looks like this. So when you have a system of equations, you have two lines, and where the two lines cross, they meet at a point, and that point is the solution. The solutions for the system is an ordered pair that represents that point. So we have a few methods that we can use to solve for systems of equations. One, we can graph. And this works when we absolutely don't need an exact answer. This is an estimation because sometimes the lines don't intersect at a perfect integer coordinate. And it works when the numbers involved are relatively small, because if you have really large numbers in the thousands, it's more difficult to graph these. We have the addition method, which is also known as elimination, and this works with any set of equations. And this is especially useful when equations have non-integer coefficients. And then we have a method called substitution, which works well when one of the variables has no coefficient on it, and it works well if one line is horizontal or vertical. Okay, so solving a system of equations with graphing. We first have to graph the line. So if you look, you'll see that we have one line that is in y equals mx plus b. Sorry about that. We have one line that is already in y equals mx plus b format, and then the other line is not, but this line looks like it'll be good to graph using intercepts because both 3 and 4 divide evenly into 12. So I'm going to graph this line using red, and I'm going to use the intercepts. So I'll have 3x equals 12. Dividing both sides by 3 gives me that x is equal to 4. So on the x-axis, I'll put a dot at 4. And then I have 4y equals 12. Dividing both sides by 4, I get that y is equal to 3. So I will put a dot on my 3. And then I need to graph a line, which pretend it's straight through those points. Now this line I'll graph using blue. I have a y-intercept of -1, so I'm going to put a dot on -1. And then my slope is 3, which is the same as 3 over 1. So I'm going to go up 3 and then over 1. So I'll go up 1, 2, 3, and then over 1. And then I will connect those points. Now I'm looking at this red line that I drew. And since I didn't have a ruler, I wasn't able to draw it straight on this tablet. But if I look at it, I think it would actually go through this point. And so the solution to this system would be the point 1, 2. So the solution is 1, 2. Okay. Again, though, that doesn't always give us an exact answer. So we can use something called the addition method. Now there's two types of problems using the addition method or elimination. One is just using plain addition or subtraction, and then the other is using addition or subtraction with multiplication. So what we do is we look at our x's and we look at our y's. I have a 4x and a 1x, and I have a 1y and a -1y. If I look at this, if I were to add those together, they would cancel each other out. This is why this is also known as elimination. So I'm going to add these two equations together. I add x's, I add y's, and I add the constants. So 4x plus 1x gives me 5x. 1 minus 1 is none. And 2 plus 3 is 5. I now have 5x equals 5. I've eliminated the y, so I can solve for x, and x is 1. Once I have x, I can then use this value, plug it into one of these two equations, and then I can solve for y. And you can pick either equation. I'm going to use x minus y equals 3 just because it's small and easy. So I have 1 minus y equals 3. I replaced the x with the 1 that it was equal to. I'll subtract 1 from both sides. I have negative y is equal to 2. That means that y is equal to negative 2. And my solution to this system is going to be the point 1, negative 2. Looking at another example, I have 3x and negative 3x. I have y and y. Now I can cancel the 3x's out because one's positive and one's negative. So when I add these together, I'll have no x's. Y and y is 2y. 4 minus 2 is 2. Divide both sides by 2, and y will equal 1. I then plug that into one of these two equations up top. I'm just going to use the top one here. 3x plus y is equal to 4. Plug in the 1 for y. Subtract 1 from both sides, and I get 3x is equal to 3. Divide by 3, and I get that x is equal to 1. So my solution to this system is the point 1, 1. This is the point where those graphs would cross. Okay, when the coefficients don't match but have things in common, we'll have two examples of this. If I look at this, I have an 8 and a 6 and a 10 and a 5. Nothing's going to cancel the way it is. This is when we have to use elimination, which is going to have addition and multiplication. Okay, I need to make these into the same coefficient. I have an 8 and a 6 and a 5 and a 10. Now this 5 can easily be turned into a 10. So I'll have a negative 10 and then I can have a positive 10. So what I need to do is to turn a 5 into a 10, I multiply by 2. But I need to multiply every term in here by 2. So I do 2 times the 6, 2 times the 5, and 2 times the 2. This gives me a new system. But this system is equivalent to the original system. So 2 times 6 gave me 12, 2 times 5 gave me 10, and 2 times 2 gave me 4. Since I multiplied every single thing by 2, I didn't change the value of this equation. I just am representing it in a different way. I can now add these two together. Negative 8 plus 12 gives me 4x. Negative 10 and 10 cancel out. 24 plus 4 is equal to 28. I divide both sides by 4, and I get that x is equal to 7. Then I come back to one of my two original equations, and I need to solve for y. I'm going to go ahead and use the bottom one just because everything's positive and really it doesn't make a difference. So I'll have 6 times 7 plus 5 times y is equal to 2. So 42 plus 5y is equal to 2. Subtract 42 from both sides. And I have 5y is equal to negative 40. Dividing by 5 gives me that y is equal to negative 8. So my solution to this system is going to be the point 7, negative 8. Over here, I have two ways I could go. I have a 4 and a 2 on the x, negative and negative, and I have a y and a negative 2y. So negative y and negative 2y. So I can either multiply this top equation by negative 2, which will make this positive 2 and negative 2. Or I can multiply this bottom equation by 2, which will get rid of the x's and leave me with y's. I'm going to go ahead and do that. But again, it doesn't matter which one you do as long as you can make them cancel. So I'm going to get 4x minus y is equal to 20. And negative 4x minus 4y is equal to 20 also. 4x and negative 4x cancel. Negative y and negative 4y will give me negative 5y. 20 and 20 is 40. I divide by -5, and I get that y is equal to -8. And then I can plug that back into one of my original equations. So if I say 4x minus y is equal to 20, that gives me 4x minus -8 is equal to 20. That's positive 8. So 4x plus 8 is equal to 20. Subtract 8 from both sides. 4x is equal to 12. So x will be equal to 3. So my solution to this is 3, -8. Sometimes the coefficients will have nothing to do with one another. So if I look at these examples, 6 and 5, I can't turn a 6 into a 5 or a 5 into a 6. I can't turn an 11 into a 16. Here I can't turn a 10 into an 11 or a 4 into a 10. So now I need to find the least common multiple of two of the coefficients. Okay, so looking at our first example, I have a 6 and a 5, or an 11 and a 16. I'm going to work with the 6 and 5 because I know they both go into 30 pretty easily, and if I look at the 11 and the 16, I'm going to have to multiply 11 times 16 to find this multiple, and I just don't really want to work with anything that big. So what I need to do is I need to multiply this entire equation by 5, and that'll make this a positive 30. Then I have to multiply this one by -5 to make this a negative 30, so that they'll cancel out. So I'll have 30x plus 80y is equal to -110. And here I'll have -30x minus 55y is equal to -75. Now I can add those together and the x's will eliminate. So 80 minus 55 is 25. So 25y is equal to -185. Divide both sides by 25, and this is not going to divide evenly, so I can either give a reduced fraction or I can give a decimal answer. If I give the decimal answer, it is -7.4. Now you can see, since I have a decimal answer, this would have been impossible to get an exact solution with graphing. Now that I have my y, I go back to one of my original equations and plug it in to solve for x. So 5x plus 11 times -7.4 is equal to 15. So I have 5x minus 81.4 is equal to 15. I'm going to add 81.4 to both sides. So I'll have 5x is equal to 96.4, and dividing by 5, I get 19.28. So my solution to this system is going to be 19.28 -7.4. Looking at my second example, I have an 11 and a 10 and a 4 and a 10. I'm going to use the 4 and the 10. So I'm going to multiply this one by 10. Oh, no, not 10. Sorry, by 5, because I'm going to turn the 4 into a 20. And then this will be a positive 20. I need to turn this into a negative 20, so I multiply the whole thing by 2. So I'm going to have 55x plus 20y is equal to -180. And then I'll have 20x minus 20y is equal to -40. When I add these together, my y's will cancel. So I have 75x is equal to -220. Divide both sides by 75. And I'm going to get that x is equal to -2.93 repeating. So we'll just call it 2.93. If we were going to use a fractional answer, these would both divide by 5, which would give me 44 over 15. And I can use that as an answer as well. Picking one of these equations, I'm going to use the 10x minus 10y is equal to negative 20. Okay, so I'm going to have negative 29.3 minus 10y is equal to negative 20. I'm going to add 29.3 to both sides. And I get negative 10y is equal to 9.3. Dividing by negative 10, I'm going to get y is equal to negative 0.93. So my solution is going to be negative 2.93, 0.93.